Applications of proportions. Our objective is to use proportions to solve problems involving geometric figures, as well as use proportions and similar figures to measure objects indirectly. Why learn this? Proportions can be used to find the heights of tall objects, such as totem poles that would otherwise be very difficult to measure. Let's start with some vocabulary. Similar. Figures have exactly the same shape, but not necessarily the same size. Corresponding sides and angles. Two figures are in the same relative position. So, if we look, we have AB is proportional to DE, BC to EF, AD to CF. Sorry, AC to DF. And then you have the measure of angle A equals the measure of angle D. The measure of angle B equals the measure of angle E. And the measure of angle C equals the measure of angle F. You will be learning more about these symbols in geometry. Find missing measures in similar figures. Find the value of x in each diagram. Alright, so this is telling you that triangle RST is similar to triangle BCD. So that little symbol means similar. Well, if you look, R and B are in the same spot here, so they correspond to each other. S and C are in the same spot, so they're going to correspond to each other. And then you have T and D, they're in the same spot, so they're going to correspond to each other. So therefore, RS corresponds with BC. So the first two and then the first two here corresponds with BC. Well, to set up a proportion, you need more than just 8 and x going together, but you also have RT and BD. They correspond to each other. So RT and BD correspond to each other. Now you can set up a proportion. So we have 5 over 12 equals 8 over x. And just like in a previous lesson, we can now cross multiply to simplify. So we have 12 times 8 and 5 times x. And we want to get x by itself, so we're going to divide both sides by 5 and simplify. So x is 19.2. Which means that the length of x, since that's what we're looking for here, so the length of x or the length of BC, since the length of x feet is BC, is 19.2 feet. Let's try one that's a little more challenging. So we have one figure where we have F, G, H, J, K, L is similar to M, N, P, Q, R, S. So we have 1, 2, 3, 4, 5, 6. So we have 2 hexagons that are similar to each other. Alright, well, let's look at the numbers and stuff that we have. So we have GH. So GH is the second and the third one. So the second and the third one are NP. So NP corresponds with GH. And the other piece of information that we have JK, or KJ. So we have J and K. They are the 1, 2, 3, the fourth and the fifth. So the fourth and the fifth would be Q and R. So QR corresponds with JK. And now we can set up our proportion, now that we know which pieces go with what. So step 1, set up a proportion. So we have 6 over 4 equals x over 2. Now it's very important. Notice how the 6 and the x, this figure, if it's on the top, it stays on the top. If you have 4 and 2, it's on the bottom. You could have done 4 to 6, like 4 over 6, but that would have meant that it equals 2 over x. So you have to keep everything lined up. All right, so now let's cross multiply. So we have 4 times x and 6 times 2, which gives us 4x equals 12. We want to divide both sides by 4 because we want to get x by itself, so it's a one-step equation. And when we do so, we end up with x equals 3. Therefore, the length of QR is 3 centimeters, since everything is in centimeters here. Let's try a measurement application. A totem pole casts a shadow 45 feet long at the same time that a 6-foot-tall man casts a shadow that is 3 feet long. Write and solve a proportion to find the height of the totem pole. Alright, so we want to assume here that both the man and the totem pole form right angles to the ground. Otherwise things are going to get kind of a little bit messed up, so we have to assume some things. Alright, so the man is 6 feet tall, and we don't have any clue what the height of this totem pole is. But we know that the length of the shadow of the man is 3 feet, and the length of the shadow of the totem pole is 45 feet. So we can set up a proportion. So we have the man's height over the pole's height equals the man's shadow over the pole's shadow. Remember in the last example, we talked about how you need to make sure things are lined up. Well, the man's height and the man's shadow are both on top. The height of the totem pole and the pole's shadow are on the bottom. You could have flipped them, but they would both have to be flipped. Alright, well, let's do cross products. So we have 6 times 45 equals 3 times x. Okay, so now we want to get x by itself, so we're going to divide both sides by 3. It's a one-step equation, because this says 3 times x, so the opposite of multiplying is dividing. And when we divide by 3 on both sides, we end up with 90. So the totem pole is 90 feet tall. Would have been rather difficult to measure with a tape measure, but we can use similar figures to help us out. And that ends our lesson on applications of proportions.